Hi, I'm Doc Palmer. I'm the author of McGraw-Hill's best-selling reliability book, The Maintenance, Planning, and Scheduling Handbook. Deals with the people side of maintenance, particularly the productivity and the quality pieces of maintenance. It's not the only parts of that. We need supervisors, managers, skilled craftspersons of all. But planning and scheduling is a competitive edge. It's not just a best practice. It's a competitive edge because it's an unusual practice to master. Most people think planners are supposed to tell craftspersons how to do their job, and for some reason that leads to resentment. Instead, we want to run planning as a Deming cycle where planners do triage and we turn the work over to skilled craftspersons, and then we act as craft historians, the planners do, to update the job plans over the years, especially with the knowledge that the skilled craftspersons are putting into our system. So as a system, we have better quality over the years. The productivity piece happens immediately when we fully load weekly schedules with the estimates that come from these job plans. The estimates don't have to be perfect. They're judgments of what the job should take. There's great inaccuracy in that. But over a week, these estimates tend to level out. We have fast people, slow people. We don't know exactly what's wrong with something. But we don't just put extra time in there just in case. And we need to fully load the schedules, even though we know we'll have reactive work. The purpose of scheduling is to help us complete more work than we would normally complete. It's not to complete the schedule. If the purpose was to complete the schedule, we would just underload the schedule and do the 2 or 3 jobs we put on the schedule and not meet the purpose, which is to challenge us to do as much work as we have labor available. So we've talked about that previously, but now we're in a series of lessons actually going through the example work orders in Appendix D of the handbook. So I'm going to share my screen and we're going to come up with one of those work orders and look at that today. This is work order number 25, and in the 4th edition of the handbook, it's figure D-19. We want to look at the request, the job plan, and the feedback and make some points just as an example to help us in our learning. We're looking for 3 primary things in a good work request. First is we want the asset number. So this has the caustic suction piping, and on a engineering drawing and a plant numbering system, it's number N00HC-036. That's great having the particular specific asset number. The name is great, but everybody calls something differently. There's a common name, a specific name, a correct name, and there's a slang name for something. But technically, this is the N00HC-036, and that is the engineering name for that is the caustic suction piping. And it's got several small leaks. That's great. We want the symptom, which is it's got some leaks. We don't want a work order to just tell us we need to replace the piping. Maybe we can patch the piping, or maybe it's not the piping that's leaking. Maybe it's something dripping down on the piping, but they have given us the symptom. Now, we welcome a suggested solution. Some of these operators and people that write work requests have been out there for a while, and they've got a pretty good idea of what we're going to do, but we definitely want the symptom, not just the suggested solution. So got the asset number, the symptom there, and the priority system, we want attention to that. Now this is R2. The R doesn't mean it's reactive. We have safety is S, environmental Z, reliability is R. Efficiency would be H at a power plant because that's heat rate, and then G would be something else because it's a required field. Stop my phone from ringing. The 2 is good priority. It's not a 0 emergency or a 1 urgent where it has to be done this week. A 2 can wait till next week, so we consider that proactive. Even though we're repairing something, it's proactive, and then our system allows us to wait until next week, and we got enough notice where we're not jumping through hoops to work on it. A 3 could be done anytime this month, and a priority 4 is something we just don't want to forget about. It could take longer than a month. So got a great priority for us. Was attention to that. I've got the asset number, and we definitely have the symptom of the problem. We'll talk about deficiency tags in another session sometime. It's a helpful device, best practice to avoid duplicate work orders and make sure something has been written up. You don't have to worry about that. And also help us find exactly where they're talking in the system, where the situation is. That's the deficiency tag. On the plan section, the planner directs it to this mechanical crew. That's the planner's job to get it to the right craft and crew. The planner thinks we should remove all the 3-inch suction piping, cut and thread new piping, and install 1 pipe hanger. And then the planner is going to have an insulation contract to remove and then later replace the insulation. At this plant, that insulation work is done by a contractor, and the planner mentions that. It's going to take a tech 17 hours. A tech is in between a helper and a senior mechanic. A tech is kind of like a junior mechanic, still a journeyman. And I especially like this estimate, 17. We work a 10-hour shift at this plant. I get nervous if I see 1, 5, 10, 15, 20, just multiples of the shift. So the planner's thinking this job is going to take probably about 2 days, but I don't think it's going to take an entire 2 days. So almost 2 days, but not quite 2 days. I just see that the planner is thinking in their mind what the technician is going to go through to replace this piping. So definitely like the estimates. Then also the less estimate is just a lump sum time for a typical maintenance job. It's not an hour for this, 2 hours for this, 3 hours for this, 4 hours for this. The entire estimate, is just a judgment. It's got a lot of plus or minus in there. So we just want to see enough. We want to see enough information, which is that block of time to allow us to do weekly scheduling and daily scheduling and assigning of the work. The planners listed the pipe that we'll need, probably about 15 feet of that, some couplings and a pipe hanger listed that. And in addition to the mechanic box, especially in the tools, we want special tools, some large pipe wrenches. And this is the place under tools that we would list safety gear for that. It is a Caustic. I'm calling out a note for that. And then a portable pipe machine that would be, I guess, for threading the new pipe. And then the installation work, of course. A cost for that out there. That's a decent job plan. We're not telling the mechanic exactly how to go about doing their job. They're a professional craftsperson. We're saying, this is the scope. This is kind of what we think we'll need. Go to it. Feedback. They installed the new suction pipe. That's better than just saying done. I do like to see that. Maybe it's possible they got out there and were able to patch the thing. And once the job goes to the mechanic, it's their job. They're the professionals. In an operating theater, the triage is this patient's got this problem. The doctor opens up the patient. It's that doctor's patient to make the right call and do stuff. We don't want anybody blindly following a job plan once it gets to the craft. Then also, they installed a drain valve, which was not called for in the plan. I think in this case, if they installed something new, they would have to get an engineering approval. But so I presume that is they replaced the drain valve that was there because it was faulty and needed attention to. And look at that. They didn't take the whole 17 hours. Parkinson's law, the amount of work assigned expands to fill the amount of time available. In plants that are not fully loading weekly schedules, we might well see that 17-hour job take 17 hours. But because we're fully loading the weekly schedules and we're moving toward a focus of work, knowing we'll have reactive work, but our goal is to try to complete that work. Typically, you'll see the 17 hours or maybe fewer hours occasionally. Now, we don't want people slopping out the jobs. Quality is all king. But it is interesting they just took 10 hours to do this job. They were moving on to another job. They took their time, did this job right, and it did not take the nearly 2 days to do that. So, good example of a good work request, a good, especially first job plan, and great feedback going nearly beyond done or something like that. So I'm going to stop the sharing here. I'm going to close this screen. And I want to thank you for letting me be part of your maintenance family and hear my ideas and things and share my information in the handbook. Also on my website, palmerplanning.com, there's conference presentations, magazine articles I've written, and also a heads up on public workshops that I do from time to time. So thanks again, and we'll join you next time.